All right, lesson 6.2 homework. Let's talk through some of these things, and we're going to learn a little bit more about the z-score. What is a standard score measure? So a standard score is another reference for the z-score. Okay, they can call it a standard score, a z-score. You can see, as it said, also known as a standard score. What does a standard score measure? So a standard score, we can look here, gives the number of standard deviations between the original measurement and the mean of the distribution. So basically what it tells is the number of standard deviations of measurement is from the mean. So it tells you, so if you have a z-score of 2, that means you're 2 standard deviations above the mean. If you have a z-score of -1, that means you're 1 standard deviation below the mean. Okay, so that gives you number 1. Number 2, does the raw score, now the raw score is the value that you have, okay? So like in the notes, the raw score was 6.9. The raw score was 6.9. It's our value. Does a raw score less than the mean compared to a positive or correspond to a positive or negative z-score? What about a raw score greater than the mean? So if you have a raw score that's less than the mean, what is that going to say about your z-score? If your raw score is less than the mean, what's your z-score going to end up being? I didn't mean to click that. A raw score less than the mean. If your raw score 6.9 is less than the mean 8, that means this difference is going to be negative because this is going to be less than that. So that means your z-score is going to be negative. What if our raw score was greater than the mean? What if it was 9? Okay, then your raw score would be greater than that, so it ended up producing a positive z-score. So raw score less than the mean will have a negative z-score. A raw score above the mean will have a positive z-score. So if it's less than the mean, it's going to be negative. That means it's below. That's so many standard deviations below. If it's positive, that means so many standard deviations above. Okay, 3. What is the value of the standard score of the mean of the distribution? I didn't do a good job of explaining this. Okay, I talked. This is in the notes, but I didn't go over it. The value of the standard score of the mean of the distribution is 0. Why? Because when you're at the mean, how many standard deviations are you away from the mean? 0. So the mean, the value of the standard, and we're going to use this here in a moment. So if I'm looking at the standard normal distribution, the mean is 0 and the standard deviation is 1. I just gave away the secrets for the next one. So when I'm talking about the standard normal distribution, the mean is 0 because when you're at the mean, your 0 standard deviation is above the mean. The standard deviation is 1. That means every time you go up a standard deviation, or you're like, if I go up 1, 2, or 3, I'm that many standard deviations above or below the mean. So the value of the mean of the standard normal distribution 0, and the standard deviation is 1. So this is for the standard normal. We will be using this here in a moment. Okay, so hang on to that. All right. So let's calculate some z-scores. Okay, z-scores, and they give you a way to standardize across variables. We haven't even got to look at that application, but I've got a normal distribution on 5. I got a normal, and it has to be, by the way, you have to have a normal distribution to be able to use the z-scores for them to have meaning. Okay, if it's not normal, the z-scores aren't going to have as much, they're not going to have the same meaning. So mean of 24, standard deviation of 5. So the z-score is the raw value, which is x or x bar, minus the mean over the standard deviation. They used x there. You could use x bar. Some books use x bar there. You could use x. So that's your formula. So find the z-score corresponding to an x of 19. So I'm going to put my x in there, minus the mean, divided by the standard deviation. You could do that in your head, or you could type in your calculator. What's 19 minus 24? -5. -5 divided by 5, -1. So, you could, if you do it all, don't do this. 19 minus 24 divided by 5. Whoops, I didn't mean to do it by 8. I'm sorry. Divided by 5. Don't do it like that, because it's what this is doing 19 minus 24 divided by 5. If you do this, put parentheses around the top. Okay. So it's -1. Find the z corresponding to an x of 38. So an x of 38. So I'm going to put my x, 38, minus the mean, 24, divided by the standard deviation, 5. So 38 minus 24 divided by 5. I can do it 2 separate parts like that, or I can do 38 minus 24 and then divide by 5. I could do it in one piece like that. Okay. So whatever you want to do, it's 2.8. So 2.8. You could also use Desmos on this too if you wanted. Find the raw score of a z of -3. So find the raw score of a z of -3. To find the raw score means we're trying to find what? We're trying to find x. So in this case, you're trying to solve for x. They're giving you z, and I should have wrote z equals there. I was getting sloppy there. So they're giving you the z of -3. They want you to find the x. The mean is 24. Standard deviation is 5. So let's think. How can I do this? And you can do kind of guess and check if you want, but how basically you're solving an equation. I've actually seen this on the ACT before too. How could I solve this? What could I do first? Multiply both sides by the standard deviation. I want to get that out of the bottom. Okay, that's what I would do. -15 equals x. So get that standard deviation on the bottom. So multiply both sides by the standard deviation. And then next, what I can do is I can get the raw score by itself by just adding the mean to both sides, adding 24. So 9 equals x. So the raw score would be 9. Find a raw score corresponding to 1.3. So 1.3 equals x minus 24 divided by 5. So the same thing. You want to multiply by the standard deviation, then just add the mean, okay? So not too difficult. This kind of a little algebra 1 type concept here. Okay, 5 times 1.3 be 6.5 equals x minus 24. You get a decimal here. Add 24, add 24, plus 24, 30.5. So this is how you do the, so you could use Desmos if you want as well. Whoops, I didn't mean to put a comma there. So that is a simple using the calculating z-score, solving for a specified value. Okay. So that's a kind of basic concept there. Okay, 6 is an example of how you can apply the z-score, doing it across multiple variables. So we've got two different groups here. We've got Raul received a score of 80 on his history test, where the class mean was 70 and a standard deviation of 9. He received a score of 78 on his biology test, with the class mean was 70 and the standard deviation is 4. So let's look at Raul. He's got his history test. He received a score of 80. What does 80 represent? That's the X, or the X bar. That's your raw score. And he's got a mean of 70 and a standard deviation of 9. Let's look at biology. And you don't have to write, you could probably do this in your head, but I'm just writing it down so you can follow along. He got a 78 on his biology test. So he got a 78. The class mean was 70. And the standard deviation was 4. So we're trying to see which one did he do better on relative to the class. So relative to the class, what do you think would be our what do you think I want to find to prove which one was better relative to the class? I want to find the what? I want to find the z-score for each class. So I'm going to find his z-score for each class. So his z-score here is his raw score minus the mean divided by the standard deviation. So I've got across two different classes here. I'm trying to compare which one did Raul do better. So 1.11. So he was 1.11 standard deviations above the mean in his history class. Pretty good. Okay, pretty good. Now let's see what he's doing in biology. Now, biology, you can kind of see where this is going. His raw score minus the mean over the standard deviation. 78 minus 70, that's 8. 8 divided by 4 is 2. And so which test do you do better relative to the class? So which one for me would be biology. Now, I know his history score is better. Like he has a higher history score, but when you're talking about which one's better relative to the class, you want to use a measure like a z-score. A z-score allows you to compare relative to the class because you can use the standard deviation and you could compare the values there, okay? Because sometimes one class might have a more difficult class, so they might have a lower mean, okay? So just because he made higher in one class doesn't mean that's... So we would say the biology one's more impressive. That's a more impressive score, even though it was lower relative to the class. Okay, fawns between 1 and 5 months old have a body weight that's approximately normal with a mean of 25.6. This is number 7. And a standard deviation of 3.2. Convert the following x intervals into z intervals. Okay, so x is less than 30. So on A, when I say x is less than 30, what do you think? I've got a mean standard deviation, so I want to convert to a z interval. What do you think this 30 represents? This 30 would represent the what? This represents the raw score, the x. This represents the raw score, the x. So what I'm going to do is, it's not that difficult. I'm going to plug 30 in for the raw score minus the mean divided by the standard deviation. I'm going to plug 30 in for the raw score and convert this 30 into a standardized score, which is a z-score. So this isn't that bad. If I'm going to do it all at once, put parentheses around the top. Okay, make sure you do this on the test. 1.375, 2 decimal places. So 1.38. 1.38. So 1.38 is going to be my value. So all you're doing here is just converting these to z-scores, okay, these x values to z-scores. So it's not as difficult as it looks, okay? And then we're going to work backwards on the next one. This is a good question. I like this question, okay? On the next one, I'm looking at 19 is less than x, so x is greater than 19, so I've got to find my z. So my raw score is this, minus the mean divided by the standard deviation. Okay, so I can come back up here, press enter, and plug in 19 there. Negative 2.06. Okay. All right. A little tedious, but this is kind of a good example to look at. This is laying the foundation for things we're going to be using for the rest of the year. So this is a good lesson to do. I don't think it's probably overly difficult for you, but so 32 to 35, I'm going to treat these like raw scores. I'm going to do this separately. So 32 minus 25.6 divided by 3.2, and 35 minus 25.6 divided by 3.2. So I'm just going to do that. So 32, and I can go back up here and grab this up here, press enter. 32 and 35. Okay. 2 and 2.94. 2 and 2.94. So 2. Yes. Yeah. Okay, let's look at D. Now we're going to work backwards on this one. So this one, we're going to convert the Z intervals to X intervals. So what I'm going to do here is, I didn't mean to do that. I'm given a Z score, and I've got to convert it to X. I got to work backwards here. Minus the mean divided by the standard deviation. It's a two-step process to get the raw score by itself. What do I need to do first? Multiply by the standard deviation. Okay, so 3.2 times negative 2.17, negative 6.944 equals x minus 25.6, and then I add the mean. Add the mean. So plus 25.6. So I multiply by the standard deviation, add the mean. You could do that process every time. You could kind of get to the point where you can take shortcuts on this. How many decimal places? 1 decimal place. Uh-oh. I would have missed that. 18.7. Right. On E, I'm given a Z of less than 1.28. So I'm going to plug in 1.28 in for my Z. I'll do that over here. 1.28. The Z equals the raw value, which is X, minus the mean, which is 25.6 for me, divided by the standard deviation. So my Z equals the raw value minus the mean divided by the standard deviation, okay? So I'm going to multiply by 3.2, multiply by the standard deviation, get that out of the bottom. So 1.28 times 3.2, 4.096. And then I'm going to add the mean, add 25.6. So I'm going to add the mean, so add 25.6. 29.696, so 29.7. Okay, so 29.7 there. Can you go up for just a moment when you're done? Yes. Okay, so F, we've got I've got two of them here. This is taking forever. I know. I apologize. But this is good. It's a good problem to look at. So you plug the negative 1.99 in for the Z. You're solving for the raw score. Your mean is 25.6, and your standard deviation is 3.2. So I'm going to multiply by the standard deviation. You're going to have to do it twice here. Negative 1.99 times 3.2, negative 6.368. X minus 25.6, and you're going to add the mean. Plus 25.6, plus 25.6. So 19.232. So 19.2. I'm sorry, I'm running out of room here. I should probably go, well, let me go to 1.44. I'm going to go full, or kind of full screen here so you could see both. So my other Z was 1.44. So I'll do that equal to X minus the mean divided by the standard deviation. Okay. So I'll multiply by the standard deviation. I know this is getting tedious here. 3.2 times 1.44. Then you add the mean, 25.6. So 4.608 equals X minus 25.6. We add 25.6. We're using a little algebra today. 30.2. 30.2. Okay. 19.2 to 30.2. I don't know why I keep on putting commas there. Okay, now we're going to look at some applications, something we didn't go over well enough in the notes. Okay, so if a fawn weighs 14 kilograms, would you say it's unusually small? Explain by using Z values. So how do I find if it's unusually small? What do I do? What does 14 represent? 14 is my X. So 14 is my X. So I'm going to find the Z score. So 14 is my X minus my mean, 25.6, divided by my standard deviation, 3.2. So I'm going to plug in 14 for X. I'm going to test to see if that's unusually small. Now, what's unusually small? That kind of depends on the book you read, like who's reading it. Negative 3.625 is what I got for my Z score. Would you say that's unusually small? Yes, small because it's negative and it's more than 3 standard deviations. So this weight's 3.36 standard deviations below the mean, so it's unusually small. It's unusually low weight. Be careful, unusually low weight for the fawn. Some people say more than 2 standard deviations below is unusually low. Some books say more than 3. So it kind of depends on the book, but 3 is very unusual. 2, but as I said, some books say 2 is unusual. Okay. If a fawn's unusually large, would you say the Z value would be 0, -2, or 3? Which one would be an unusually large? Which Z value would correspond to an unusually large fawn? 3, right. Now, some argue that 2 would be, now, -2 is unusually small, but, some argue that 2 is unusually large. Okay, so you kind of it depends on who you're asking on what's unusually large there. Okay, so some people say 2 is, some say 3. So it's a little inconsistent depending on the book you read or who you're talking to, but 3 is definitely unusual. All right. This is something I've not covered yet. So this was not in the notes. So I've got you're going to get mad at me, but this is not that hard. So what you're going to do is I'm going to click use salt. We're going to find the area under the curve for the indicated interval. This is something we're going to be doing a lot tomorrow. Find the specified area, answer the 4 decimal places. Okay. We're going to use the normal distribution. So I'm going to click use salt. The area to the left of Z equals 0. So let me show you what's going on here. Left of Z equals 0. I've got a normal curve. This is kind of a white trash normal curve. Z equals 0. 0 is the mean. 0 is the middle, okay, for a Z value. Left of 0 would mean I'm wanting to know this region right here. What's that area? Now, y'all can guess. What do y'all think the area is going to be? Left of 0, left of the mean. What would that be? Okay. All right. We'll come back to that in a moment. Now, anytime you're talking about a Z interval, a Z, A z distribution always has a mean of 0 and a standard deviation of 1. So you're going to click normal distribution, and you're going to always use mean of 0 and standard deviation of 1 for z. Okay, tomorrow we'll use something different. X value corresponds to the z value. So my z value is 0. Okay. Now, if I'm looking left of 0, am I talking about left tail or right tail? Or in between? Which one? If I'm left of 0, I'm talking about left tail. So left tail, and the answer is 0.5. Okay, so it's 0.5. It's my probability. So 0.5 goes back. So I'll go back to there. It's 0.5. Okay, now think about this. If you're at the mean, y'all have answered this right before. If you're at the mean, what percentage is at below the mean? 50%. So that's kind of what I was trying to get you to see earlier. All right, sketch the curve. Now, you don't have to sketch the curve. I will, but you can sketch the area of the curve and find the indicated interval. So this is not that bad. I've not taught this, Joe. So you can blame me for that one. So I've got a normal curve, okay? 0 is the middle. Where would negative 1.41 be? To the left of 0 or to the right of 0? Don't think too hard. Left of 0, right? Negative 1.41 would be left of 0 because it's below 0. Now, if I'm talking about left of negative 1.41, am I going to be shading to the left of this point or the right of this point? Left. Okay. So here's how this works. Keep in mind, I can click use salt, or I could go back to my original salt one. My mean is 0. My standard deviation is 1. When I'm talking about a z, the z distribution, it's mean 0, standard deviation 1. I'm winding up probability it's left because it said left again. But what's my x this time? My x this time is this z value, negative 1.41. So I plug that in there, and then I get this value right here. This is my answer. Okay, so it does all the work for you. I just didn't cover it. So I'll do Control C. So 0 and 1 left, because it's left of that, and then I put in my z-score. Okay. And I've got to go 4 decimal places, so I think I've got 5 here. So I need to go 3 at the end. Okay. All right. Okay, now let's do the area to the right. Now, I think you're getting the hang of it. I'm kind of going slow here, but you're way faster than me. If you're talking about a z distribution, 0 is the middle. You don't have to write it down. You can do it in your head, but I'm doing this for teaching purposes. To the right of 1.64. Let's establish first where 1.64 is. And I know this is an estimate. Is 1.64 above 0 or below 0? Above, right? So it's somewhere above here. I don't know exactly where it's at. That's probably not right exactly, but that's fine. Now, if I'm talking right of 1.64, am I going to shade the left area or the right area? Right. Now, you don't have to do this, okay? I'm doing this, as I said, a million times. I said doing it for teaching purposes, but I'm just trying to show you, visualize what's happening here. You can kind of do this off of SALT. This mean of 0, standard deviation of 1. As I said, that's going to be different tomorrow. I'm wanting to know 1.64 is my x because that's my z. And I'm wanting to know which tail this time. Right tail, because I'm shading to the right. So shading to the right. The normal distribution is probably I think you're going to like it a lot easier than the binomial distribution. It's honestly a little easier. So you're probably going to, pick this up a lot faster, which is good. Oh, I didn't do that right. I'm sorry. I didn't click. Oh, I put positive 1.64. It's positive 1.64. I'm sorry. It's positive 1.64. I don't know why I put negative. That's on me. Positive and right. Okay, that's going to be wrong. So I caught it. I apologize. I'm not perfect. It's actually 1 minus that because it's the complement of that. All right. I don't multitask very well. All right, 11's an interesting one. 11, as I said, this is setting up for tomorrow. So this is good. We're going to get this out of the way today. The area between 0 and 3.12. So 0's in the middle. Where's 3.12? Above or below 0? Now, when I'm talking about the area between 0 and 3.12, where do you think I'm shading? Don't think too hard. Between these two. So I'm shading in between, okay? So we're going to use the between feature this time. So in this time, it's still a mean of 0 and standard deviation 1 because it's a z-score. But we're going to use the between feature this time, okay? And so my lower bound is 0, and my upper bound is 3.12. Okay, and it does a good job. Okay, you see so there's that Control C. It does a pretty good job. This is pretty straightforward here. Okay. You don't need to draw the curves. I know this is probably getting a little easy. The area between 0.42 and 1.81. So once again, you could draw this out. You don't have to draw this out. I'm just doing it for teaching purposes. So 0 and 0.42 is above 0 and 1.81 is above 0. Between means I'm going to shade where in between the values. As I said, you could just probably a lot easier if you just went straight to salt and did this. So 0.42, I'm going to keep the between feature selected. 0.42 is my lower bound. 1.81 is my upper bound. Salt's very user-friendly with the normal distribution. So I really like using salt here. Very user-friendly. I need to round this. So I'm going to have to change this to 1 at the end. Okay, so I'm going to have to round that. Probably had too many of these questions on here, but this is something you're going to use a lot throughout the next little bit. Lastly, 13, the probability that z is less than negative 0.22. Less than negative 0.22. So you're going to find this value and you're going to shade the corresponding normal curve. I'm actually just going to go straight salt here. So less than negative 0.22, mean of 0, standard deviation 1, left tilt because it's less, and negative 0.22 goes here. Okay. So this gives me the answer, but then I could use this normal curve, and you probably don't even need the normal curve to get the answer, but 0.429. Now, normal curve, the shading, it starts, or it looks like it goes up to negative, so it goes forever to the left, and it goes on the right, it goes to negative 0.42, so it's not even going to hit 0, 0. So we're not going to hit 0. So we're looking for one that starts at negative 0.42, or starts at negative and basically negative infinity. It goes to negative 0.42. Should be this one right here. Okay, so it kind of matches that one. That's your homework. All right.